Bismillahirrahmanirrahim. October 18, grade 42, and question number 7 topic is work power energy. And mass given 0.3, this particle mass 0.3, released from rest, so U0 is falling down. Okay, so this is in free space, and after that it hits the surface of water. I can show in circle, but I show a line to understand. This velocity remains same. He says in the question, in no instant change in velocity. So this speed and this speed plane, the final of this is equal to the start of this. So this situation, particle hits, and let's see what the question we have to find. So what speed did reach the ground? Okay. So let's start. First of all, this is stage number 1. So free fall. Okay, we can say free fall out of water. Free fall out of water. Out of water. Okay. So let's see what happens then. U is 0, time takes is 0.8, and my target is to get the last velocity, and but this data and gravity is equal to plus 10 coming down. So I can say here V is equal to U plus 80 or GT. Last speed is a question, U0, gravity 10 and 0.8, and we got 8 meter per second when it will hit the surface. So this is 8. I just mentioned here, this is 8 meter per second. Okay, so this is also 8 meter per second. Okay, so now this motion, this is U, and let's see what is the oxygen. He given us that the work done against friction in the water, against water, is 1.2 joules. So this I can, and distance is given also. So using these two, I can find the friction force. How? Work done by friction force equal to F into D. And this I'm keeping here, and this I'm keeping here. So I can get friction force from here, okay? And let's calculate this friction force, which is 1.2 divided by 1.25. It is coming 0.96 newtons friction force. Okay, let's talk about step number 2. Now fall and in water, in water, what is a motion in downwards? In water, downwards. So let's see what happens now. Okay, this V becomes U naturally, and as we have 1.25. Issue is we want velocity, but before velocity we need acceleration. So first find acceleration, and particle is for example, this is a particle. It has a weight component, so this is a mg, okay, and backward is a friction component, and that's it. So let's see what happens now. So net force equal to ma. Okay, so mg minus friction force equal to ma. So mg is 3, friction is 0.96, mass is 0.3, a I need to find. So let's see what a comes in this way. So it becomes 3 minus 0.96 and divided by 0.3. It gives us 6.8 meter per second. Okay, square. Now I can find, we have data, so 2as equal to b square minus u square, and 2 times 2 is 6.8, s is 1.25, v is a question, 8 is this one. So 8 comes here, so v root of whole, so 2 times 2 so 6.8 into 1.25 and plus 8 square. So let's type it. So 2 times 2 6.8 and into 1.25 plus 64 gives the 9 sharp answer. So it means 9 meter per second is our answer for this part. So part first is over, we got it. Part number 2, he is asking us, so find out, okay, what is the situation in part number 2? He says when the particle reaches the bottom here, it bounced back vertically upward, initial speed 7. It means I will make this diagram again to understand, okay? So let's see what happens then. Okay, so this is a surface of water. It goes back Okay, situation is this here, and let me, okay, this one, and let's go maybe a little bit up, okay, let's see what is situation, okay. He says that vertically upward, the speed of 7, so this u is 7, okay, and it experiences friction force is given here 1.8, and particle come to rest after it bounced back on the bottom tank, so find t. So this time is our target, this time is a call t1, and this time is t2, and our target is a both, so add them both. So let's see how we can find it, okay. So situation is this distance is 1.25 mentioned here, depth of the water 1.25, okay. So we have same situation, one particle going upward, let's say applied force, weight component, and this is a mg, this is a friction force. Now net force equal to ma, okay, applied force minus friction force minus mg equal to ma. But as you know, there is no applied force because it is going due to inertia, so applied force is 0, as applied force is 0. So what happens, this friction force 1.8, mass is 0.3 into 10 is equal to mass times 2 acceleration. So let's find acceleration, negative 1.8, negative 3, and divided by 0.3, it comes negative 16 meter per second square. So it means it's decelerating, and this is a, okay. So we can find this speed, okay, and time even, okay. So let's talk about formula, so 2as is equal to v squared minus u squared, 2 times 2 negative 16, s is 1.25, and last speed is my question, u is 7. So it goes there, so v root of 2 times 2 negative 16 into 1.25, it adds plus 7 square is 49. So let's see what answer comes. 2 times 2 negative 16 times to 1.25 plus 49, and it gives us 3 meter per second. Okay, but I need the time even. So this v will help us to get this one. So I can say that the what is the time? So v equal to u plus at, okay, and v is a 3, u is a 7, acceleration negative 16, and time. So 16 come here, it goes there, we got a 4, and time is coming 1 by 4, 0.25 seconds time in water. This is in water, okay. Now going upwards, out of water surface, out of water. So what situation now? So this v becomes, this v here becomes u, 3 meter per second, okay, and last speed is confirmed 0 because it stops there, and gravity going negative 10, my target is find time. So v equal to u plus at or gt, last speed 0, u is 3, gravity is this, and time becomes 0.3. So this is a t2 actually, this is a t1 actually, t1 and t2. So total time is what? So total time is t1 plus t2. So answers become 0.55 second, and that's it, and questions is over. Alhamdulillah.